When I'm preparing for a swim, I imagine absolutely everything about it. The color of the water, how cold it is, the taste of salt in my mouth. I visualize each and every stroke. These golden words can only come from a master, a legend. And they are the words of Lewis Gordon Pugh. To the point, I earnestly hope that the two lessons on mathematized trigonometry and mathematized calculus clearly demonstrate that there is indeed a space for mathematized mathematics. In other words, all of school mathematics must be mathematized. Mathematics education needs to be unabstracted, demethodized, visualized, verbalized, and every solution to questions be thought-fueled and not reflexive. Of course, mathematized mathematics is just my expression for real AI-age mathematics education. Mathematics education needs to be such that no one is left behind, with no exception. No human child should ever struggle with mathematics. For at least 2,000 years, humankind has approached it incorrectly. Mathematics education is grossly misplaced, and what school calls mathematics is not what mathematics should be for children. Especially in the AI age, where abstract mathematical skills and traditional measures of success are of little value. We must change our approach. And for this, only one change is needed. We must stop teaching mathematics in the traditional way. We need to reimagine and rewrite school mathematics resources so that every home becomes a nursery of mathematics learning. More cogently, mathematizing mathematics is about democratizing mathematics learning. It aims to propel mathematics to be the first humankind-wide cultural common, the first human development goal assurance. The mathematized mathematics couldn't come at a better time in the AI age. It organically synergizes the dreams and energies of over 8 billion people in harnessing and leveraging the power of AI. Practically speaking, mathematized mathematics is to empower you to be a lifelong, independent learner of mathematics and, most effectively, utilize AI to achieve your dreams and deeds. As significantly, mathematized mind is cognitively more expansive and incisive, and better at system thinking, decoding compound situations, fostering a research mindset, and logical connectedness of thoughts and actions. Mathematics teaching strips mathematics of its logic and language DNA. It ignores mathematics as the language of science, reality. Specifically, the mathematization of mathematics education is about achieving near 100% learner centricity of the concepts, concept map, problems, and solutions, leaving the lessons learned and applied to be deeply personal. All mathematical instruction should support the visualization and verbalization of every concept and problem in secondary education, and the majority of the concepts and problems in senior secondary education. Broadly, this mathematization involves 4 steps: visualize, verbalize, virtualize, and validate. We will present an example each of the 4 steps. Visualization of mathematical expression ensures that the expression accurately represents the quantities in question. For instance, if we consider x into sine x as representing the behavior of a variable quantity, then can we vividly imagine the graph of x into sine x? The graph of x into sine x is shown. Could you imagine it to be the way it is shown? We should be able to. As another example, let us consider a simpler one to visualize, x plus sine x. The graph of the same is shown. The difference between the two graphs should be easily visualizable in broad terms. When we add 1, 2, 3, 4, and so on to sine x, we can see it as 1 plus sine x value at 1, 2 plus sine x value at 2, etc. This is shifting up the sine x curve by those amount. In effect, it becomes a sine curve along the y equal to x line. On the other hand, sine x multiplied by x is 1 times sine x at 1, 2 times sine x at 2, and so on. In effect, it is like amplifying the sine x values and increasing amplification of sine x with increasing x. Thus, the graph has increasing amplitude as x increases in both directions. The point being conveyed is that all school mathematics can be visualized, and this is a very real and cultivatable mathematical ability. While it is true that all functions can now be visualized using simple applications, Seeing a system-generated function curve is never the same as personally visualizing it. The visualization must be personal, at least during the school years. No technology aid is advisable. Verbalization is like logicalization of the visual imagery, readying the imagery for mathematical expression. A well-verbalized statement is the ideal foundation for accurately expressing mathematical ideas. Attempting to verbalize x into sine x would be somewhat advanced example. Let us verbalize a simpler expression 4 into 3 into 2. This can be verbalized or read as 4 sets of 3 pairs of things. I must place on record how Bodmas or PEMDAS would interpret 4 into 3 into 2, reading left to right. 4 into 3 would be 12, and then 12 into 2 would be 24. This differs from how I have verbalized 4 into 3 into 2. In my defense, I would point out 2 issues with Bodmas. First, it is an oversimplified set of rules for highly abstract, education-focused mathematics. Second, contradictions are to be expected if it is visualized. Let us verbalize another expression, 4 divided by half divided by 2. It would be read as how many halves in 4, which would be 8 halves, and then how many 2 halves are in 8 halves, and that would be 4 2 halves. Next, the precise verbalization is translated into mathematical expression. This expression will lose the context. For example, 4 apples repackaged or regrouped as 8 half apples will be written as 4 by half. This step is called virtualization because it is the abstracted equivalent of the verbalized expression. For instance, 4 by half can represent any 4 things divided into half. 4 and half are virtual quantities waiting to be made real as per context. Validating is the process of mapping the virtual, the mathematical abstraction, with the visual and verbal representation. In general, validating the outcome, the virtual representations, with the inputs, visual and verbal representation, is a distinguishing feature of mathematics. Why is that so? Because it is so possible always. More than in science. Mathematics relies heavily on logical consistency and rigor, allowing for precise validation of outcome against their initial descriptions and representations. In my personal experience as a polymathic school-focused educator and author, my body of work manifests 2 diametrically opposite gifts of a mathematics-trained visual and verbal ability. First, it supports and ingrains the habit of reasoning, prompting endless questions of why and how well beyond mathematics. How does mathematics seed this endless whys and hows? It is the only field of knowledge that has logic as its DNA. Thus, everything in mathematics is connected by why and how. Getting the clear big picture, as well as understanding the logical connections, both vertically and horizontally, becomes the default mode of thinking and being. For instance, you would be naturally seeking a lot of physics in physical geography and a lot of historical context in human geography. The second gain, and opposite of the first, from mastering mathematized mathematics is the nurturance of visceral drive too, the growth of instinctive and unreasoning thinking. Of course, in due course, these may be logically rooted, but they better qualify as a kind of deep-seated feel or wisdom. Let us first aim for and secure a higher level of mathematized mind. Then we can consider the overall cognitive and academic gains that follow. Unprecedented economic miracle awaits humankind if all the 8 billion people are mathematized thinkers. Hereafter, no one can be left behind in learning mathematics. Mathematized thinking is the true goal of mathematics education. Secure it for yourself and your family. Mathematics is like a first language, highly visual, verbal, and deeply personal. Success in mathematics is cognitively enriching. Thank you. With us, you will master all the mathematics you need. Be good to you, not just others.